Hello everyone, thank you for attending today's session. And today we have Minjie Zhu from Oregon State University. He's a research associate in structural engineering, and he works with Dr. Michael Scott. And today, and he's one of the, or he's the developer for OpenSeesPy, the OpenSees version. So it's really great to have you today, and it's all yours now.
Yeah, thanks, Pavan. Thanks for inviting me for this presentation. I'm glad to have this opportunity to talk about the OpenSeesPy with the end users. Usually I quarantine myself in my office or now my home, do a lot of coding. I don't see a lot end users. So this could be a very good opportunity for me to talk to you guys directly. So the purpose for me today is just I want to get some inputs from you guys and see what we can improve on our side as the developers. And also I want to give you some informations about how to contribute to the OpenSees. Instead of just using OpenSeesPy, you can actually contribute. When we talk about contributions, people always think about, oh, it's C++ programming. Oh, it's too difficult. But it's a lot of times you don't have to code in C++, but you still can contribute through Python, through documentations, through your projects examples. So hopefully my slides are not too technical. If you have any questions, just stop me and ask whatever. Yeah, it's not clear to you. Okay, so now I'm gonna just share my screen. Okay, so the topic I'm gonna present today is the OpenSeesPy development and contribution. So in the first part, I will introduce the development of OpenSeesPy, where it begins and where is the current status. Then I will give you some information about how to contribute. So when we talk about the OpenSeesPy development, you probably already know OpenSeesPy is based on the OpenSees framework. So all the codes development, I mean, at the C++ level, it's all in the OpenSees framework. So it's a good starting point. So we get some information about the OpenSees classes. Even you're just OpenSees users, you may never use these classes, but I think it's good information you can know, so it will help you to do the OpenSees analysis. So for OpenSees, we basically have two major components, the domain and the analysis. So the domain, you can imagine, is just a storehouse. So you have nodes, elements, constraints, load patterns, everything that compose your model that's stored in the domain. And another big part is the analysis. Analysis computes the states, the current state for the static analysis, and you also compute the state for the next time step if it's a dynamic analysis. So that's the two major components. Like elements, materials are all in the domains. But things like integrators, how do you do the load integrator, the displacement-based integrator, or Newmark dynamic integrator, or algorithms like methods, and the like constraint handlers, these things are in the analysis. So that's the two major components. They're in the core of the OpenSees. At the other side of the OpenSees framework is the inputs. I believe Sylvia has made a good presentation last week, if it's not last week, last presentation, talk about the Tickle-based OpenSees.
2 weeks.
So for OpenSees Tickle, yeah, this is the user inputs comes in. You have the model builders, then the Tickle model builders gets the inputs from the Tickle script and creates whatever user wanted and add them to the domain object. The problems with the Tickle model builder. Tickle model builder has been very deeply binded with the Tickle language. At one hand, it's a good thing because you can utilize the Tickle language itself to do very quick user inputs. But however, the problem might arise when you want to do other languages, such as Python, MATLAB, Ruby, and there's a lot other, we call the glue language or scripting languages. Because the binding with the Tickle language, the model builder, if you want to extend OpenSees from another language, you need a new model builder. And that model builder need rewrite all APIs for each language. That's a lot code rewriting. And another possible problem is you probably get some different results from different interpreters because the way different interpreters get the inputs and give the outputs. So in a research conducted in 2018 with Frank, me, and Michael. So we did called multi-interpreter interface. So the idea behind that is if you observe the code we call APIs in OpenSees, most of the codes for each API is the same for almost all languages. For example, if you want to create a node in OpenSees, you get the user inputs, user nodal coordinates, velocities, this information, and you test this, you check this information, you add it to the domain and see if there's already a node with the same tag. Then you return the node tag back to the user and notify the user that the node is successfully added. So the only parts that are different between these different languages are the inputs and outputs. And between the inputs and outputs, all the codes are the same and should be the same for all these APIs. So with that observation, we think we can abstract these non-interpreters or non-GUI parts of the APIs. So we make abstraction of all the APIs, the same codes for all different languages, and only leave these inputs and output stages for the implementation or extension to like Python or other languages. So this we call multi-interpreter interface. This figure is a little bit too much. Sorry for that, but that's the best I can make. So if you look at this here, OpenSees IO APIs, we defined 8 APIs called IO APIs. Only these 8 functions are different for different languages. If you can read the name, you get the idea behind these APIs. So get integer input, get double input, get strings. So that's get inputs functions. And set output, integer output, set double output, that's the output APIs. When you're able to implement these 8 functions with Python or with MATLAB or with Ruby or with Tcl, you're able to extend OpenSees to that language. And all other functions or APIs, we call OpenSees core APIs, the codes are exactly the same for all different interpreters. Like
Ask you a question? Did
Yeah.
you say you can do this in Ruby as well?
Theoretically, it's possible, but I haven't done it.
Okay.
Yeah. Yeah, thanks for asking. Yeah, if you have any questions, just raise your hands and ask. Okay, so this node command, element command, material commands, these commands are just exactly the same. So this saves a lot of time for developers like me to avoid the rewriting of these core APIs. So that's the whole idea behind the OpenSeesPy interpreter. So now it's just Python because Python is so popular today. But in the future, there might be other languages. So we make it's very easy to switch the language. You just need to implement these 8 functions. So adding a new language just need implement 8 IO functions. All others are independent, interpreter independent. So OpenSeesPy is just an implementation for the Python language. So you can do for the Ruby and anything else like Lua, a lot. But there's a limitation. There's a limitation for this approach because we want to cover all languages. That means we need to make assumptions for how these languages handle inputs and outputs. So the interface we used is just use the plain data types, integers, doubles, and strings. So we believe that that's common for all languages, right? All languages use these 3 data types. And we use only called positional arguments. That's a Python language, but it means we assume each parameters, input parameters are called by their positions. You call a function, you have first, second, third arguments or parameters. Things like the Python keywords features is not available because that's not commonly shared by all languages. Now I can show you an example of the core API. So there's 2 pieces of code. So this Python code, we create a list and loops the list to create 4 nodes. That's the same thing we did for the Tcl. So when we call the node command, they are calling exactly the same core API, the node API. So you can see here, we get the domain, we check the domains, we check number of arguments, then we get the tag, we get coordinates. So the exact same piece of code is run for different languages.
Can I ask you a question about that?
Sure.
Sorry to ask so many questions, but
Yeah, no
I
problem.
just picked up Python the other day, so I'm all excited about it. Going back to that interface there. So what I like about Tcl is that this input here, what you see in line 7, is actually validated as a string. So if I'm in 3D, I could actually have 6 different inputs or however many variables.
Yeah.
In your Python, you actually have an array with 3. In 2D, you've got 3 inputs. In 3D, you would have to define it differently. So how could you make it variable based? You would have a different command for 2D than you would have in 3D.
Yeah.
Or is there a way around it?
Yeah, the answer is here. So you see the get coordinates.
Okay, so it's a variable size.
Yeah, we get double inputs. We take the number of dimension, this number of coordinates it can be 2D or 3D. So this, yeah. So if it's 3D, we just use X, Y, and Z. You get a third or fourth argument in the node command.
Okay. So it's a command. It's not really just an array, but okay.
Yeah, it's a variable array, right?
Okay. Thank you.
Yeah, sure. Okay, so that's for core API. And in the core API, we see this, we have a get double input. So that's the only place different interpreters or languages are different. If the interpreter is Python, so this input API called the Python implementation, Python get double. So internally, we call the Python API, pyfloat as double. So that's get the Python inputs if we call OpenSees in Python. And if we do Tickle, we use Tickle APIs, like here, Tickle get double. So we only have 8 of these functions. If you implement 8 functions, you're done with that language. You don't have to rewrite everything. So that's the whole idea. To create a core API in OpenSees, this is more for C++ developers, but I think it's still good information to share. There's 4 steps if you want to create a core API, like the node command or element command. So first, you declare your API function with the name. The name always starts with OPS, underline, and API name. You define it in the OpenSees commands.h. So this function is in the source directory interpreter subfolder. And then you implement your API in one of these source files. It depends on what kinds of API it is. Either output commands or utility commands or a general commands. Or you can define in its own class .cpp, like this one, OPS elastic beam 2D. So this API create an elastic beam column element. So if it's element class or element command, you can define in its own class .cpp. Once you're done with the implementation, then you need to register your API. So there's 2 options. So if your API is a subclass of a top-level class, OpenSees has several top-level classes like the element, uniaxial material, or sections. If it's a subclass of these classes, you register your API in this source file, OpenSees element commands or OpenSees uniaxial material commands. Or if your API is a standalone, means it's not a subclass, it's just like utility functions. You need to register API with the wrapper. Yeah, I can show you the wrapper, because when you define the API, you need let Python know or let Tickle know this API is exposed for the language. So it takes a while to, okay. So like here, if I want to expose this command to Python, I go to this file called Python wrapper and register this new command with the name and the implementation of the command. Then I add this command to the Python. So with these 4 steps, then you can add a new core API. So this is a very brief introduction to how to create a class, a new class. But new class, I mean either an element class, you develop a new element for reinforced concrete, or a new material section pattern. Sorry. No. Yeah, here. So if you have a new class, either a domain class or an analysis class, you need first subclassing this from the base class. Then you implement it. You need to do configurations for Linux or Mac or Windows. Then you add your new API, the core API. Then you need to compile the OpenSees module with the new class. You need to download from the OpenSees repository. So that's about contribution. We'll talk about that later. Then you also need to write a small Python examples to test. So I walk through this very briefly, just give you an information, an idea. How do we do when we create class or we create APIs? If you really need to add something in OpenSees, you can contact me or Sylvia or Michael for more informations. Okay, so this is for development. So now, the OpenSeesPy is a new user interface. It's not graphical, but it's interpreter interface on top of the OpenSees framework. So with that, you can extend it to any languages easily. So if you have done this development, then you need to consider how to contribute back to the OpenSees framework. So for now, OpenSees has moved to GitHub. So GitHub is just web service for hosting open source. Also for closed source codes, but it's free for open source projects and for developers. But you have to need a GitHub account to do any contribution. So just go to github.com, create a free account. For these free projects, I think everything is free to contribute to do the development. It's all free. For OpenSees, okay, then we need tell different repositories. So the first is the OpenSees main repository. So if I can show you, go to the main repository here. So here is the main repository for OpenSees. So all the C++ codes are here. For interpreters, for the OpenSeesPy interpreters, it's in the source interpreters. So I just present it in the first part. So these codes are all here. So that means there is no OpenSeesPy repository in terms of the source codes. So all source codes are in the main OpenSees repository. If you have done this development, I just talked, then you want to contribute, here's the steps you need to do. First, you need to fork the repository. And maybe you can show you. Yeah, here. So if you go to the main repository, here's a link called the fork. You need the account to fork it. Then you will have a forked repository in your own account. So you developed in that account, in that forked repository. Then you need to clone or copy the forked repository to your local machine. Then you do your development locally, most likely in C++. You need to compile it, make sure there's no errors, there's no bugs. We know everyone have bugs, but at least it can run locally. Then you need to push your changes to your forked repository in your own GitHub account. And lastly, you submit a pull request to the main repository. And once you submit your pull request, I think Frank or Michael and other people will review your codes and try to run your codes. If it's okay, they will merge your codes to the main repository. The good thing about GitHub is when you do this pull request and the changes, so it's recorded in with your information, what changes you made, how much contribution you did, like how many lines of code. It's all recorded. It's good for your personal credits to do the development. You can see here, OpenSees now currently have 35 developers. So if you have just one line contribution, your name will be recorded here. So it's good for yourself too. So this is for contributing C++ to OpenSees. Then we talk about this OpenSeesPy contribution. So like I said, OpenSeesPy is built on top of OpenSees. So all the core functions are in OpenSees, but with the Python's packaging feature. So here we use the called Python package index, called PIP. So this is a package management for Python. So basically, it takes the OpenSees, the module. So it's a DLL file in Windows.so file for Mac and Linux. So this packaging system take that file, that's the binary file, and add on top of it with pure Python scripts that can extend basic OpenSees functions with new features just in Python. So if C++ is too difficult for you, Python might be easier a little bit. So currently, OpenSeesPy adds some extra features to OpenSees Tickle: float structure interaction, pre-processing, post-processing. This all under development. Pre-processing is pretty simple. We need more contributions from users like you. Post-processing is in a better situation. Now we have two post-processing or plotting packages added to the OpenSeesPy. One is called Get Rendering, developed by Denova. No, by a user from yeah, you're right. Right, and also another one is from a user from Poland. These are two good plotting functions. So you can just do plotting in your Python scripts in the same script and do the nice plotting like MATLAB. I think that's the place we welcome all the users to contribute. You can add extra functions, pre- and post-processing, or utility functions, or even examples, tests to this to the OpenSeesPy package. And it just needs Python scripting. You don't have to know anything about C++. You don't have to compile it. You just write Python scripts. And here, this is the repository for this Python package. So this repository called OpenSeesPy, some people think that that's the source code for OpenSeesPy. It's not. It's just a place to have all the information together. It has 4 subfolders. OpenSeesPy PIP. So this is the packaging of extra features for OpenSeesPy. If you want to contribute, like I said, the Python functions, you contribute to here. And it has a copy of OpenSeesPy documents. So that's the document website for OpenSeesPy. It's in the read the docs. But that's just a copy. It's a copy of another repository. It has also OpenSeesPy Docker, and it has the copy of the main OpenSees repository. So both these documents and OpenSees are copies. You don't modify them. You only modify this OpenSeesPy PIP. So if I can show you what it looks like. So if I go to here. So when you do in your script, you do import OpenSeesPy. So go to this folder, OpenSeesPy, OpenSees. So that's the place it goes to. It checks your operating system to import correct OpenSees. And if you want post-processing features, so that's the files for these plotting functions of OpenSeesPy. So you can see this is all Python scripts, not C++. Okay, let me get back here. So to contribute to this PIP folder is exact the same procedure. The fork, clone, debug in Python, and you push and you submit a pull request. So I just walk through this quickly. If you want a detailed information, you can contact me or Pavan. Lastly, I want to talk about how to contribute to the documentation. The documentation is, we have all the manuals for the functions, for all OpenSeesPy functions. I believe many of you have checked this website for documentation. So this is the repository of the documentation. What you need to do is to write called the REST function document. So it's a special language. But okay, so that's rendered. I show you the raw. So basically, when you add something or you find some bugs or some problems, you create or change this file. So this is totally text file. It defines the function name, function description, arguments. So if you have new functions or you find some problems in the documentation, or you have some examples you want to share with the community, contribute to this documentation. This package we use is called Spinix. That's a Python packaging, a documenting package. It's easy, not hard to use. And once you contribute to this repository, it will automatically compiled and post to the website. Okay, so yeah, so that's yeah. I want to conclude this presentation. That's development and contribution. We're welcoming all the contributions, and we also want to listen to you, what we can do to improve your user experience with the OpenSeesPy, what you want to improve, what you want to add that is missing currently. Is there anything make you very painful when you use OpenSeesPy? And you need something, you really need that. I want to listen, I want to know what we can improve or do. Here are some ideas I can think, but I know you probably got better ideas than I do. So thank you for listening. So and it's time for me to listen to you. Thank you. Any questions?
Thank you, Minjie. It was great to see the back end side of things, and I hope this acts as reference for someone who is trying to do similar stuff in future and contribute. And it's amazing that you showed everything end to end, like in 30-40 minutes. Yeah, and please, everyone, feel free to ask questions or suggestions. So, I mean, if no one is asking, I can start with myself. Uh, you sounded it a little simple, like doing the whole 8 points interpreter, making things. All we need to do is make 8 functions. So if it is simple, then why are there not many languages apart from Tcl and Python so far?
Why still we only have Python? We have Python and Tcl, right?
I mean, Python is also very recent, right? So like,
yeah.
So is it really complicated to do those 8 functions, or like?
No,
Python?
it's not that hard. It's basically you go to Python. Python has its own C APIs.
Yeah.
So you need take the parameter as the integer, and you call the Python integer APIs. You get it from Python, and everything else is done. I would say it's not that hard, but it does need some low-level programming with Python. It's actually called CPython, so it's the Python interface with C language. But that part is handled. Yeah.
And I have one more thing, which I personally faced issue with the contributing when I was doing. I was having the examples, and you asked me to send them in RST files, and I had no idea what RST files were and how to get them. And I tried online, I couldn't get a good overview of how to convert. Can you please tell me that now at least?
Yeah, I know. You have some experience, right? Too.
But I didn't convert them into RST files. I gave you, and like you did it. I never did it because I didn't know how to do it.
Yeah, so so the RST format is used by this called Spinx. If you go to this link, so this is the homepage for Spinx, Python documentation generator. So you write what you need in certain formats, and this generator will generate the web pages. Initially it takes some time to get yourself familiar with called this RST, restructured text.
Okay.
Yeah, so it's basically formatted texts like Markdown. It's a little bit more complicated. For example, if you want to write a hyperlink, so if you want to write a hyperlink, you do this. Use the symbols. I don't even know the name of it, but you put your link here with this brackets around it, and also further limit with the symbols and with an underline. So that becomes a link in the web page. So it's a formatted text. If it's, yeah, I know probably for most users, that's a little bit too much.
Yes.
Yeah. Yeah, if you find it's too hard for you, you can send me the just in plain text file, like the names, parameters. I can help to convert that. Yeah, that should be okay.
Yeah. Other question.
So
question.
Oh,
Go
sorry. So I had a quick question. So I just started using OpenSeesPy on a Mac, and I know in the most recent release, you actually, with that version, you don't have to compile it yourself, right? You can just import it and it works. But you are forced to use the homebrew Python, which is really messy in my opinion. So I like to use Pyenv to control my Python versions, right? It's a lot cleaner to control the different versions of Python. Is there any, what's the plan with that moving forward, I guess?
Yeah, the Mac version is you know, is a little bit messy right now. Yeah, the one of the reasons is I don't have a Mac. I just got one like 1 month ago, so I start using it and compile the homebrew Python. So for me myself, I just start learning Mac, you know.
Yeah.
So there's another version called OpenSeesPy Mac.
Yep.
Developed by the Steve. He's not actively developing it, but I know he just got a new version out. The reason I use Homebrew is he recommended.
Okay.
So I know that's the problem for Mac users. Can I know how many Mac users here? Can I get one?
There's more. There's a Nikki uses one, and there's at least 2 others.
Maybe in the chat you can type.
Yeah, maybe you can give me a just impression. What's
you
the
guys
percentage?
You can do the raise hand in Zoom.
Yeah.
Or do a thumbs down if you don't. Could that be an opportunity for them to contribute to what you're doing? And
Yeah, sure. Absolutely.
Cool.
Yeah, you can do. So from my experience, Mac is very similar to Linux.
Yep.
But you need to handle this the dependencies of the libraries. That's I'm not very good at with Mac.
No,
yeah,
it's so anyone right now. Yeah, cool.
Okay, yeah, I will write this down. Mac version. So how many? Do we have a number here?
I can't figure out how to raise my hand.
You got to go to more or raise hand.
Oh,
here we go.
Okay. Yeah. If there's more Mac users, we need to justify our time, right, and efforts to maintain it. Okay. So Sylvia, you're Mac users, right?
No.
No.
I have to use a Mac when I do the web development and things, but no, my kids use Macs.
Ask them. So I know Frank is a Mac user.
Yeah. He's a nice guy anyways, but yeah. The question for you guys then, so maybe that brings my question on there. I'm a big fan of Jupyter Notebooks.
Sure.
So is that platform not on Design Safe? I follow Mike's course, it's on my thing. Because, well, what I like about the Jupyter Notebook is the additional languages and things that you can bring in, and all the different libraries and plotting and things. So does that become platform independent then, though, because it's running off of your web browser? Or is it still a Windows? Windows?
So actually, we do our classes all in Jupyter Notebook. So all the homeworks are done in the notebooks. So that's great tool. But you can run a local server for the notebook. Yeah, just on your laptop.
Right. Could that be? Would that be different if you have a Mac?
No, because you still need a Mac version of OpenSeesPy.
Sorry. Okay.
Yeah.
So I was going to ask, that was my question, is how do you and the community feel about the Jupyter Notebooks and OpenSeesPy? I mean, I was going to move forward and I have to teach a course to a group of people on OpenSees, and they want Python. And so I was thinking of using the Jupyter Notebooks because they're just kind of a little bit more friendly than a regular IDE.
Yeah, it's pretty good. And actually, the commands are exactly the same. I mean, the Python and the Tcl. If you use Tcl before, you find the commands are just the same, but with Python variables or Python functions. So people complain that it's not Pythonic. I totally agree, because we want extendable to different languages. I cannot make it very Pythonic. Otherwise, it's not easily to change to other languages. Who knows what's the next language people are using? Yeah. Any other
Just to add one thing, there were like 4 people who raised their hand for the Mac users. 4 or 5. That's it.
Okay, cool.
Out of 27 or 26.
May I jump in? This is Milad. So today in the morning, I was running ID analysis using Jupyter Notebook on Design Safe, and it was taking just forever. And I'm a Mac user, and then because I cannot install OpenSeesPy on my Mac, I needed to just connect using remote desktop to my PC in my office. Okay. And it was like, so I think it would be really nice to have OpenSeesPy on my Mac, and just like Mac user to just run some analysis in there. Yeah.
Okay. So it should be able to run on Design Safe even you're on Mac, because that's a cloud-based.
Yeah, but Design Safe is buggy.
Well,
yeah.
Well, and if you download the newest version of OpenSeesPy, it is compatible with Mac. You just have to use Python with Homebrew, the Homebrew Python.
Right.
So you can do it, but
I haven't tried that. So is there any instruction for that?
Yeah, there's a little, I think on the newest release notes on the OpenSeesPy website, there's a little note about how to do that. And it does work. It's just, I had to make my Mac un-Mac-like, I feel like, to make it work.
Okay, yeah, Mac version, that's a big one. I take notes.
Max, the X in Max is often pronounced as a C. So I think you can help out on that one, since you're passionate about your Max.
Well, I wouldn't say I'm passionate about it. I mean,
no, it's okay. Hey, I know people. I have people in my family use Mac as well. So people I respect use it. I just like to tease you about it because I give it a chance, and I try to work with a Mac, and I just keep on throwing it against the wall. So, but then again, I'm a Tcl person. I love Tcl more than I love Python.
Python, yeah, Tcl is good.
To me, Tcl is to Python. This is what I wrote on Facebook. Tcl is to Python like a PC is to a Mac. There's so many more things you can do with Tcl that you can't do with Python.
But we are
in programming.
But But the problem is more people are using Python.
Oh, I'm with you. It's like using Word versus other programs. Yeah. So I've sold out. I'm installing Tickle. I'm excited about being able to mix it. I'm looking into the Python because I'm excited to be able to mix it with other things in a Jupyter notebook mainly, which seems like a nice basic UI.
So. Yeah. Right.
Thank
so
you for
speaking of Jupyter notebooks, I just had one of my friends just texted me, and he said that we should implement it in Julia.
What is
Yeah, Julia is another one. Yeah.
So
we need people to contribute. Maybe.
Well, the interesting thing is that I was reading somewhere that Python and Tickle can actually share the same interpreter. And so based on what you have done, it'd be interesting to see if we can mix certain things. So there's some nice features of one and nice features of the other. So if we could do a mixed language version, it'd be really nice.
Yeah, that's the PIP packaging comes for.
Yeah.
Customization or add-ons, through just Python.
Yeah, well, because I've developed the UI in Tickle and TK. I'm a big fan of TK, and so it'd be nice to be able to bring in some of your features from Python. Though.
Okay. Yeah.
I'll let other people speak now.
any other questions from other users?
I have a question. Are there any examples on how to contribute to let's say to post-processing functions? Because probably some of us have some codes but don't really know how to contribute.
Okay. Yeah, it depends on you want to contribute to the existing post-processing library, which is in OpenSeesPy right now, or you have your own library or just a couple of Python files.
I mean, like not that very specific question, but rather like both the scenarios, I'll say.
Okay. Yeah, I think the let me go to,
because like having some examples in the documentation might help.
I will say the easiest way is send me your Python files if that's easiest for both. But the reality is I don't have so much time to do all this all by myself. So I would recommend to, if you're interested or anyone interested, you can try to do a contribution to any GitHub. Start with that. So GitHub is, I would say, a great place for sharing code. Not just OpenSeesPy, you can share your codes. You can create your own repositories, just sharing your own codes. But so I think it's a good benefit for you too to learn some the process how to do that in GitHub. So I will say that's good for you or any users if you can learn a little bit. It's not that hard, but if you do not want to do yourself, I will say you still can send that to me. I can make it available just in the documentation and put your name there, because we want this it's a community, right? So everyone contribute, everyone benefited. Yeah.
I have one more thing to add there. So one of the things which, as an early user, most people face is the resources, finding resources in one place, or like, I mean, I even emailed you about it. You said, but like it would be good for everyone to know as well. Like what are the plans for that?
I mean, the plan for gathering all the informations.
I mean, yeah, the resources which are more useful for someone who wants to start, like, and yeah.
Yeah, I know. It's ideally we can have like a center place, right? It has all the informations from getting started, tutorials, examples. I just don't have that time to do it. Honestly, I really want that happen. So that's I want we can work together. So I kind of view you guys not just users. I want to collaborate with everyone. So we contribute all together as open source, community. So I think everyone has something to contribute. You do have something to contribute. You don't want to bury your code or just in your own computer.
So the other thing where people can do the most contribution, I feel, is like their own research. Like they can put it as case studies. Like maybe, like for example, most of them
Yeah,
have research papers. They can put the research paper along with the code so that like people can follow what they're doing end to end, and also have the code. For someone who's starting, that's also going to be really good. I mean, a suggestion, like, but for that people need to come forward and give. I don't know how many would be doing that, but at least I would like to do that in future.
yeah. Even you just have few lines of codes that could be useful for other people.
Yes.
Yeah. Anything else about what features you really want from OpenSeesPy that is missing right now?
Yeah, can I?
Sorry.
Sorry. Yeah, go ahead.
Yeah, in Tickle, I couldn't find any way for how to control the threads or cores of CPU. Did you consider any module or extension in OpenSeesPy to have a multi-processing or parallel processing? Because I think Python is very beneficial in this process.
Okay, so you're talking about the HPC, so like multi-core parallel computing, right? So from Tickle, yeah, if I'm wrong, Sylvia can correct me. In Tickle, there's so OpenSees Tickle is actually a single processor program. There's a parallel versions is OpenSees MP and OpenSees SP, right? So currently in OpenSeesPy, we implement the OpenSees MP and OpenSees SP in all together. There's a command for that. I don't remember the name, but if you go to the documentation under the parallel commands, there's commands to do it. But the problem is you can only do it in Linux. It's really mass to do that in Windows. Parallel computing in Windows is horrible. So I can only do Linux. So for now, at least for now, you can do it. You can control your number of processors, number of threads, but only in Linux. Okay. I know HPC is maybe a concern for some, especially academic users. Yeah, just wonder, is that really an obstacle or consideration for you guys that HPC is an issue to stop you using OpenSeesPy or a factor that encourage you to use OpenSeesPy?
No, because for most of, for example, post-processing, it is, I found Python very easy. It is most of my, for example, I wanna compare other softwares with this one. Most of them, how to say, the post-processing or the modeling, I use Python. I think it is easy for me to have all of them in Python because of that. I mean, a little meticulous. Is it easy to have such a process, have such a paralleling in Python or not?
Okay, so you think it's a good thing to have the post-processing, right, added? Yeah.
So can I ask you a question on that one then? So you said you have the MP. Does that mean you have the mumps solver even if you use it in a single core?
Yeah.
You do, because that's supposed to be the good thing about OpenSees MP really is this mumps solver.
Right. Right. Yeah.
So because the way I do it in Windows with Tickle of being able to run many from within Tickle, I call instances of OpenSees and I run, if I'm running a lot of ground motions, I just say, I'm running in Tickle and I say, okay, call OpenSees, create this input file, call OpenSees, and on with just the regular. So I'm using Tickle to manage how many cores I use. Could you actually be in, I guess you could just call instances of OpenSeesPy or OpenSees itself from within Python, right? And run in parallel? Because you can in Tickle.
Yeah, if you run with MPI run.
Okay.
Yeah. Yeah, the OpenSeesPy Linux, if you're on Linux machine, it comes with the mumps solver. Yeah.
Okay, but so the one that you have for Windows does not come with a mumps solver, though.
No, I couldn't make it work in Windows.
Yeah. Okay.
Any other questions?
So I have a quick question. So I was using. Can you hear me? Sorry.
Yeah.
So I was using TCL interpreter for OpenSees, and then I recently started using OpenSeesPy, and sometimes yes, some of the things that are in the TCL are not in the OpenSeesPy, and some of them in the OpenSeesPy are not in the TCL. So it's really sometimes I use TCL, sometimes I use OpenSeesPy. So it's a constant, like, what to do in between these two, and especially like some of the new materials that are added to the GitHub. My question is, are all of those UniXL materials available in TCL, are also available in OpenSeesPy, or only few of them?
OpenSeesPy was designed to contain everything in OpenSees Tickle. So that's our goal. But sometimes we leave out some, we probably just forget it, or or there's new material added to OpenSees source, and we just haven't converted to Python. So in these cases, can you maybe send me an email? So what functions you find that are missing in Python, but it's already in Tickle? I believe over 90% is converted, but we probably still have something missing there. Yeah. So in these cases, I just ask people to let me know what are missing.
Okay, thank you. So in particular, I wanted to use the SL UniXL material from Professor Ligno's group from EPFL. So I could use it in TCL, but I couldn't find like any code in repository that could translate.
Okay, so what's the name? It's a UniXL material, right?
SL material.
SL.
And Ligno.
Okay.
I would appreciate.
I can take a look. If it's not there, I can add it.
Okay, thank you very much.
When I spoke to Frank about the Lignus likes to keep things in their own GitHub. So you may not find it. And then I know Dimitrios is giving me a DLL file for the new IMK materials, but also they keep, my understanding is they keep the code in their own repository, which is probably open, but you may not find it in the OpenSees repository, but you'll find it in Lignus's folder. So you might need to contact them directly, because is that material even in the documentation? I don't even know it. What does it do?
It's the steel material with buckling. Yeah, it's mostly for the steel, like those flanges and steel beams. But I don't think it's included in the documentation because it was recently added to the GitHub.
Okay.
But I would like to see that in OpenSeesPy. If yeah, we can do something.
Okay. Yeah, if I have the source, yeah, I can make it available. But if I don't,
the C like C++ file, I think it's in the repository. So
okay. Okay. Yeah. If it's there, I can share it. Yeah. Convert it. Okay.
Any other questions?
I do have a question.
Yes,
So right now, well, I'm just new to using OpenSeesPy, but I've used Python for a while now. And so with OpenSeesPy, all the commands run on arguments, right? And I was just wondering how, if it's possible at all that it could also run on quarks, on keyword arguments, and not just arguments, because I guess it's just me with the way I like to keep my code clean. Like I put all the what do you call this? All the I forgot the word. All the arguments as keyword arguments, like in dictionaries, and I just wanted the clean way to just pass those dictionaries straight to the commands. I mean, it's still possible to turn them into a list and unpack them, but I feel like there's a possibility of something breaking with that. But if it's passed as a keyword argument, then there's less probability of making mistakes.
So like just introduced in the first part, we make our positional arguments because that's the interfaces for all different languages. So native API or functions, OpenSeesPy functions are positional only. But I know there's, you always can do the tricks in Python. See if you're passing the keywords arguments, but internally they're calling the low-level functions. There's a way to do it, but I haven't tried. But I know some people are doing it, so it makes their codes looks better. Yeah, is that you're asking for?
Yeah, I mean, I can still do it right now. I'm just a little bit scared that sometimes, because I convert the quarks to args, then if my dictionary is not ordered properly, the arguments will not be passed in order. But if I mean, it's good to have. That's just all I'm saying. But if it's too difficult to do, then it's fine. I'll just have to make sure that all my dictionaries and all my keyword arguments are ordered properly to become arguments.
Right. Yeah, you got to be careful with the order of the arguments.
Yeah.
Right.
Yeah.
Right.
Yeah.
This is very similar to the. Yeah, it's similar to the issue that I was asking about with Tickle, that I'm used to sending packets of code. And so with Tickle, because it's a string, it will evaluate it as a string, so it doesn't matter. But, like Node, that I have to actually separate the different input arguments, and therefore the number of arguments depends on different conditions. And so it sounds like that's very similar to what you're saying with the Python there.
Yeah.
So,
yeah.
Right. Thank you.
Thank you.
Any other questions? Sounds like not a question. So I'll just ask one final one maybe. So what was the most difficult thing you faced in doing this, or like do you think like is going to be the difficult thing you came across while doing this, so that like others will learn from that mistake or your experience?
So what's the most difficult when I do this OpenSeesPy?
Yes.
Yeah, there are a couple of things that are very hard. Mostly are related to the the low-level Python calls. So when I start doing it, Python 2 is still alive. So it's still in the transition from Python 2 to Python 3. So I need to keep both. So I have a Python 2 and a Python 3, but I can use definitions to split them. But it was a little bit headache to keep both. So now I think Python 2 is dead, and we're all Python 3. But I know still some people are still using Python 2. And unfortunately, we don't support that anymore, the Python 2. Yeah, so I guess that was part of my PhD study, and along with other researchers. I believe most people here are graduate students, right? Yeah, so for master PhD studies, you're always facing difficulties, and you feel like you're never gonna do it. But at the end, you find you actually don't did it.
So if at all there is a Python 4 or something, then what is it going to be then? Like again the same problem?
I don't know if will be a Python 4.
I mean, in future. Okay.
Yeah, but you always, facing the problem that in the computer science side of this programming, they are developing very fast. There's always new things you need to learn. It's not like us in structural engineering. So we kind of stay there for that doesn't change a lot. But in this IT world, things changing very quickly. So now people are doing the machine learning, GPU programming. A lot of new things come out. So I think we need to do the changes, follow the changes within OpenSees. Maybe in the future, I'm not saying I'm doing it, but maybe in the future we can include these things into OpenSees.
Any other questions, guys? No? Okay, cool. I think then that will be the end of the question section. I hope everyone learned something today. At least I did. So thank you for presenting and answering the questions, and it was like really good discussion and like very high level, of course, but like it's good to know that level too. And yeah, do you want anything else to say?
Oh yeah, just thank you for this opportunity. Because I'm in a role like the developers of OpenSees and OpenSeesPy. I really need to get inputs from the end users. So if you have any questions or any comments, suggestions, yeah, just send me emails. Yeah, I need this inputs to justify my direction and my time to make it better, and hopefully it's useful for more people.
I'll stop the recording.
Yeah, thank you.
Yeah, it was really awesome.
Very awesome.
Thank you, guys.